This video will show you how to change from the metric system over to pounds and ounces and vice versa. So our first problem is the patient weighs 6 pounds and 10 ounces. What is the weight in kilograms metric? Okay, so two things you have to do. First, you have to determine what you're looking for. In any problem, that's the first step, is to determine what you're looking for. So in this case, we're looking for kilograms. You might think that sounds obvious, but actually some people don't understand that, and then they get into problems when they're trying to do the rest of the math. And then the other thing is this 10 ounces that's right here, we need to make that into a decimal. So, because it has to be, 6 pounds point something out, 6 point something ounce pounds. That's the only way we can do this problem easily. Okay, so the way to do that is you take the portion of the pound, which is the 10 ounces, and you take and you put the full portion down here. Now we know that 16 ounces are in a pound, so the bottom number is always going to be 16, and here you have it. So it's and then the rest of the equation is you have the kilograms per baby, and you have your 1 kilogram is 2.2 pounds right here, and then you have however many pounds of baby. So that's how you set up the equation. So if we take 10 ounces here and we divide it by 16, which is how many ounces are in a pound, we come up with 0.63. So now we know that the baby's weight is 6.63 pounds. Fill in the rest of the equation. Like I said, 1 kilogram is 2.2 pounds. And if you just do the math, carry it all the way out, we end up with 3.01 kilogram baby. Now, as far as rounding goes, you don't want to round until the last moment. Because you don't want to round, like say for instance, you don't want to round this figure, like 6.6. It would be 6.6. Well, we don't want to do that. We want to go 6.63, 2 decimal places. And I'll show you why. Because when we talk about a baby, we document in grams. So now I know that a lot of people would know already that if you were going to change this figure, 3.01 kilograms into grams, you would just move the decimal place over 3 spots. I can never remember whether it's moving it 2 spots or this way or whatever. So I like to put in this other piece of information. I'll show you. So I like to put in that 1,000 grams is 1 kilogram. I like to put that actually into the equation, because then when you look at how many grams the baby is, you can see that everything cancels out nicely. Here's the kilograms, here's the pounds, and you end up with grams of baby and grams of baby. And then now you can see why you don't want to round off here, because otherwise this would not be 3,013. It might be 3,010 or something like that grams. And we always want to give credit where credit is due. So we always want the baby to be the proper weight. So I hope that that explains why we don't want to round off there. Let's go ahead and do a different question. It's problem number 2. The patient weighs 185 pounds. And what do you want to do? And 10 ounces. Oops. And the weight is, what is the weight in kilograms? So again, you're looking for kilograms. So again, the formula to do this is you have to make a decimal out of 185 point something pounds. And in order to do that, you take the portion over the whole, and that would be 10 over 16. We already know what that is because it was the same as in the other problem. And then the formula, you set it up. You want a kilograms of man. You take your kilogram. 1 kilogram is 2.2 pounds. And however many pounds is the man, which is 185 pounds and 10 ounces. 185.63 pounds. So let's look at that. Of course, as I said, we already knew that. And here we have 185.63, and 1 kilogram is worth 2.2 pounds. And so we have 185.63 over 2.2, and this comes out to 84.4 kilograms worth of human being, person, man. So now as far as a man or a person, see, because 0.4 kilograms is actually almost a pound. So you probably would want to go ahead and put the 84.4 in there. Again, over here, we have it out to 2 decimal places. So we'll put the final weight in kilograms out to 1 decimal place. Okay, so now we're going to do the opposite thing. Our patient weighs 70 kilograms. So we want the weight in pounds. So we're going to go backwards. And it's the same principle, of course. You take the kilograms worth of person, kilograms in the man, times 2.2 pounds in 1 kilogram. Now, you remember in the other problem here, you had the kilograms on top and the pounds on the bottom. On this one, you have the pounds on the top and the kilograms on the bottom. Why? Because we want to find pounds, and it just cancels out nicely. So anyway, continuing on, we have a 70 kilogram man, and we're multiplying that by 2.2 pounds per kilogram, and we get 154 pound man. No decimal points. Okay. So basically, it's just you take the 70 kilograms and you times it by 2.2. That's really the shortened version of the equation. But I like to put it out like this because if you forget exactly which direction you're going or how it works, this is easy because you just cancel out and have pounds of man, pound man. There you go. Okay. So now we have a little baby who is 3,500 grams, and we want the weight in pounds. Again, it's very simple. You take now remember this 2.2 pounds is in a kilogram, and we have grams here, see? So I always like to put this into the equation because, again, if you don't remember which way your decimal points go or how many decimal points in what direction, this makes it so much easier and you don't ever get messed up with this sort of thing. So anyway, but again, it would just be 3,500 grams is 3.5 kilograms. And then we multiply that by 2.2, and we get our pounds. So, but again, in order so that we don't get confused, we go ahead and put in the 1 kilogram is 1,000 grams, and we end up with a 7.7 pound baby, which is appropriate for a baby to put the 0.7 pounds because it represents such a large portion of the weight of the child. So I hope that this gives you a good idea of how to do these kinds of problems, which you will be having on your test at the beginning of the fall semester.